Hello and welcome. My name is Alexander Moreira, and today we're going to be discussing the problem compatible pairs. In this problem, we are given a graph with n nodes, and each node has a label di and ni cows that are standing on that node. And two nodes are connected if the sum of their labels is either equal to a or b, where a and b are fixed values given in the input. Our objective is to determine the maximum number of cow pairings that we can produce from adjacent nodes. So if two nodes are connected to each other, we can pair cows from those two nodes. So let's start off with an example here, and this is going to correspond to the graph that I have on the left side of the screen. So we have 5 nodes. A is 5, B is 5, and here we can see the data for the graph. In the left column, we have the node labels, which I have marked in square brackets. And in the right column, we have Ni, this is the number of cows. So node 5 has 5 cows, node 1 has 10 cows, node 4 has 25 cows, and so on. We can see that nodes 5 and 1 are connected to each other because the sum of their labels is 6. 1 and 4 are connected to each other because the sum of their labels is 5. 4 and 2 are connected to each other because the sum of their labels is 6. 2 and 3 are connected because the sum of their labels is 5. And then 3 is connected to itself because 3 plus 3 is 6. And I claim that the output for this example is 87. So let's see how we could construct 87 pairs of cows from this graph. And we're going to want to start with this cow, or these cows on node 5. So we're going to pair together cows from node 5 and node 1. Node 5 has fewer cows, so that's going to put a constraint on us. We can only get 5 pairs of cows from these two nodes. So that's going to lose 5 cows at node 5, and we're going to lose 5 cows at node 1. Then we can continue on and pair together cows at node 1 and node 4. And again, we're going to create another 5 cow pairs. So now there's 0 cows at node 1, and there will be 20 cows remaining at node 4. That allows us to pair together 20 cows between node 4 and node 2. And that's going to leave us with 0 cows at node 4 and 15 cows at node 2. And then we can pair together cows from node 2 and node 3. Again, the constraining number here is 15, so we'll get 15 pairs of cows here, leaving 0 cows at node 2 and 85 cows at node 3. And then for these 85 cows, since node 3 is connected to itself, and only because node 3 is connected to itself, we can pair the cows at this node with each other. So we're going to do 85 divided by 2, rounded down. So that's going to give us, we now want to make a key observation. In particular, no cycles are possible except for these self loops. You could play around for some with some test cases and convince yourself of this, or you could take a look at sort of a mathematical approach. So here I have a proposed cycle between 3 cows or 3 nodes. So we have D1, D2, and D3 being the labels of those 3 nodes. And if we play around with the formulas here, let's start by subtracting equation 1 with equation 3. And that's going to give us D2 minus D3 is equal to 0. If I add that to equation 2, that's going to give me D2 plus D2 is equal to B. So I've recovered a self loop. And if you sort of play around with this, you'll see that all possible cycles reduce down to just self loops. And the nice part about having no cycles is that means we can always repeat this leaf peeling process that we did on the sample input here. So we can just identify all the leaves, group together all of the cows on the leaf node, delete it. Now we're at another leaf, group together all the cows at the leaf node, delete it, and continue on through the rest of the process, just peeling off one leaf at a time. This leads us to our solution idea, which is since there are no cycles except for self loops, we can greedily create pairs of cows starting from the leaves. So let's dive into the code and then we'll wrap up the problem. We're going to start our code here by creating a map called cows that is going to store the number of cows at each node. And then we're going to read in the values n, a, and b from the input. And if we are in the edge case where a and b are equal to each other, I'm going to set b to just some random large value so that it's irrelevant for the rest of the problem. Then we're going to loop over all the data in the input, and we're going to fill in the cows map. In particular, we're going to map each label to the number of cows that live at that node. And then we want to check for leaves. So those are all nodes that are only adjacent to one other thing in the graph, including isolated self loops. So in order to do this, I'm going to loop over all the nodes in cows, and I'm going to write this function isLeaf to detect if a node is a leaf or not. The two possible nodes that could be connected to node V are A minus V and B minus V. If both of these values are not in my map, that means V is not connected to anything else. If both of these values are in the map, that means V is connected to two things. So it's only when one of these is true and one of these is false that V is a leaf. So if they're not equal to each other, V is a leaf. Otherwise, V is not a leaf. So if V is a leaf, we'll add it to our set of leaves or our array of leaves here, and then we're going to loop over leaves and count the number of pairs we can achieve. So while the length of leaves is greater than 0, we're going to pop out the current leaf, and then we're going to record the number of cows at that leaf node. So we're going to do two checks. If A minus V is in cows, we're going to set W to A minus V. Otherwise, if B minus V is in cows, we're going to set W equal to B minus V. So this is the node that V is connected to. Note, by this condition, only one of these two conditions can be true. If neither of those conditions are true, then we should see that V is a isolated loop. So we can increase pairs by half of the value of the number of cows at that current location. So we just take our pairs and add ni over 2, and then we continue on. Otherwise, if one of these two cases did occur, then we're going to increase pairs by the min of ni and cows w. So remember, ni is the number of cows at node V. Cows W is the number of cows at node W, which is the node connected to V. So I'm just going to take the minimum of those two things and add it to my pairs. Then I'm going to decrease cows W by the amount I increased pairs by. And then I want to check, is W a leaf? If it is, I'll add it to my set of leaves so that I process that node next. And then at the end of the program, I simply print out the number of pairs. So this completes the code for compatible pairs. Thank you guys so much for watching the video, and I'll see you guys in the next one. Bye-bye.